Okay, now for the rectangle. So one thing about rectangles is that they actually are parallelograms, which means they're going to inherit all the same properties of a parallelogram. So if you just look here at the rectangle here, I mean, hopefully you know this. Opposite sides are parallel. I mean, TC, RE, those are parallel to each other. RT and EC are parallel to each other. Then we have opposite sides. Congruent. Again, if you were in class, you'd have a ruler out and you'd measure and find that TC is the same as RE and RT is the same as EC. Then we have opposite angles congruent. Hopefully you can see that they're congruent. I don't want to mark them right now because I'm just going to have to erase it a little bit later. Diagonals bisect each other. And then last but not least, consecutive angles are supplementary. So it inherits the same 5 as a parallelogram. However, it's its own independent person or shape. So it's got some definitions or some properties, I should say, of its own. The main one, what do we know about a rectangle? You probably know this to the point you don't even think about it being part of the definition. A rectangle has to have 4 right angles. All of our angles are exactly 90 degrees. So 4, that's that many right angles. So, of course, they're supplementary because no matter which way you look at it, 90 plus 90 gives you 180. So, yeah, of course they meet this property. But anyways, now it says to find 7, we have to draw in the diagonals. So I'm going to draw in my diagonal then to the best of my ability. Now, if we were to actually measure these, we would find something interesting. If I'm doing centimeters, this would be 5.2 centimeters. So that one's 5.2 centimeters. Okay, that's not really interesting per se. Of course, it cuts it in half. Duh. That's what property number 4 says. But when I go to measure the other one, this is where it gets interesting. That one's going to be 5.2 centimeters. And that one's going to be 5.2 centimeters. What do we notice about the diagonals? They're congruent. They're the same. So we're going to say for our 7th property, diagonals are congruent. Now, if I were to fold this rectangle up here perfectly in half, how many ways could I fold it perfectly in half? If you're not sure, just take a normal sheet of paper, that's a rectangle, and try to fold it in half. How many ways can you do that? Two. So rectangles have 2 lines of symmetry. You can fold it either hot dog style or hamburger style. Okay, so now that we've explored the properties, let's use those to solve some problems here. We're going to attack this one kind of like we did the other, in the sense that we're going to have to, losing my train of thought here. Well, let's find everything we know of, and then we'll go from there. How's that sound? Okay, so I know that if RE is 6 units, TC better also be 6 units. If EC is 8 units, then RT better be 8 units. Okay, so now we got to deal with angles. We've got to deal with angles. Let's think of something here. Remember how I said these have parallel lines here. There's a pair of parallel lines. Totally doing the wrong ones to show my point. Here's our parallel lines we need. And then we've got this one that comes down like this. Okay, now this one's 24, which means this one has to also be, you got it, 24. Let me erase my markings here. So this is 24 degrees right here. Okay, so let's see if there's anything else we can figure out. Well, what do I know about one corner of a rectangle? What does it have to total? This whole corner has to give me 90. I have 24 degrees. How can I find the rest? 90 minus 24. Well, it's just going to give me 66. So angle 1 is 66 degrees. And angle 5 is 66 degrees. Now, what do we know about the diagonals? Let's use those for a second here. What do we know about our diagonals? We know that these are all equal. Which means if I just look at, let's say I'm just going to look at this triangle right here. What kind of triangle is that? It's an isosceles. 66 is a base angle, so that means that two has to be our other base angle. So this one is also 66 degrees. While we're at it, we might as well say 6 is also 66 degrees. Okay, so there, we've got our 66s in there. Now what about angle 9 here? Looking at my pink triangle, I have 66, 66, and then I need to know this third angle. How can I get that? Add it up, subtract from 180. It's going to be 66 plus 66. Which, let's see, it's 12, 132. Subtract that from 180. Yeah, 48. So this means angle 9 is 48 degrees, which these are vertical. 9 and 10 are vertical, so that means 10 has to also be 48 degrees. Now, 48 and what give you 180? 48 and 132. So this has to be 132 over here. Also, even though it's all highlighted right now, each of our sideways triangles is isosceles. So I have, like, if I look at angle T, this angle is 66, but to give me 90, this has to be 24. Same with angle 3, it's got to be 24 degrees. So I think for now we've done about all the damage we can do. Let's fill in and see if we found everything. So angle 1, 66 degrees. Angle 2, 66 degrees. Angle 3, 24 degrees. Angle 4, 24 degrees. Angle 5, 66 degrees. Angle 6, 66 degrees. 7 is 24 degrees. 8 is 132 degrees. And 9 and 10 are both 48 degrees. Well, we did good on our angles. We got all the angles. Let's see about the sides. So we said RT had to be 8 units. RC. Ooh, RC, that's diagonal. Yikes. We're not done. Let's skip that one. Let's go back. Look at TC. TC is 6 units. Yikers, we're not done. Because they asked me to find RC. Now, you may be saying, but you can't. Yeah, we can. Oh, what do I have here? I got me a right triangle with a leg of 6 and a leg of 8. So let's do the Pythagorean theorem. 6 squared plus 8 squared equals x squared. It's going to be 36 plus 64. 100. Square root it. And we get x equals 10. So all the way from R to C is 10 units. And then it asked me, okay, well, fine. What about E to A? Well, E to A is right here. Now, if R to C is 10, that means this has to be 5. That's got to be 5. Because remember that diagonals are bisected. So what's that mean about EA? That's got to be 5. And TA has to be 5. So EA is 5 units. OBKB. So that's rectangles. We're working our way through it. Stay tuned for the next shape.